Hello, everyone. We are from the ROAS Academy faculty team. Today, we're going to dive into a topic from your CBSE Class 10 mathematics curriculum. We're in Chapter 2, Polynomials, and we'll be focusing on the geometrical meaning of polynomial zeros. Now, for any similar video explainers, please feel free to connect with us at ROAS Academy. The number is 8910-890311. I'll repeat that, 8910-890311. We also have another number, 8910-600-503. Again, that's 8910-600-503. All right, let's get started. You've probably spent a lot of time in algebra class hearing about the zeros of a polynomial. But what does that word actually mean? Today, we're going to pull back the curtain and see what these zeros really look like when we put them on a graph. It's one thing to solve for x, but it's a whole other thing to actually see it.
So here's our game plan. First, we'll nail down the basic definition of a zero. Then, we're going to build our understanding piece by piece, starting with simple straight lines, then moving on to those cool curves, parabolas, and cubics. By the end, you'll see there's a super simple but powerful rule that connects everything. And of course, we'll test your new visual skills at the end.
Okay, first things first, before we can start spotting zeros on a graph, we need to be crystal clear on what we're even looking for. Let's start with the pure language of algebra.
You know, on paper, it's actually pretty simple. A zero is just a special number. You take your polynomial, which we'll call p of x, and you plug in this special number, let's call it k, for every x. If the whole thing calculates out to be zero, then congratulations, k is a zero of that polynomial. That's all there is to it. But here it is, the big question for today. That's all great for algebra, but what if we drew a picture of this polynomial? Where would this zero be? What does it look like? That's what we're here to figure out.
Let's start with the absolute simplest case, a linear polynomial. You might remember from class 9 that when you graph these, you always get a perfectly straight line. So, let's take a look at y equals 2x plus 3. To draw this, all we need is a couple of points, right? So, if we plug in -2 for x, y works out to be -1. If we plug in +2 for x, y jumps all the way up to 7. We just plot those 2 points, draw a line straight through them, and boom, there's our graph. Now pay close attention. This is where the magic happens. Look at where our line crosses that horizontal x-axis. See that point? Its coordinates are -3/2, 0. Now, let's think back to the algebra. If you set 2x plus 3 equal to 0 and solve for x, what do you get? You get x equals -3/2. Whoa! It's the exact same number. This is our first major clue.
So here's the bottom line. For any linear polynomial, it has exactly one zero. And that zero is just the x value of the point where its graph crosses the x-axis. One intersection means one zero. Simple as that. Okay, that was a straight line. Pretty, well, straightforward. But what happens when things get a little more interesting? A little more curvy? Let's level up to quadratic polynomials. These guys form that classic U shape that we call a parabola.
Let's check out this example. Y equals x squared minus 3x minus 4. If we start plugging in some values for x, something cool happens. When x is -1, y is 0. And, check this out, when x is 4, y is also 0. So just based on our algebra definition, we've already found two zeros, -1 and 4.
Just a quick side note on these curves. The way they open depends on the term in front of the x squared. If it's positive, the parabola opens upwards, kind of like a smile. If it's negative, it opens downwards, more like a frown.
Okay, this is where parabolas get way more interesting than straight lines. They have options. In the first case, the curve can dip down and cross the x-axis at two completely different points. That gives us two distinct zeros. But what if it just barely skims the axis? In case 2, the very bottom or top of the curve might just kiss the x-axis at a single point. That means it has exactly one zero.
And that brings us to our third and final possibility. What if the parabola is just floating? It could be entirely above the x-axis or entirely below it. If it never crosses and never even touches, what does that mean? Well, it means it has no real zeros at all. So the big takeaway for quadratics is this. A polynomial of degree 2 can have two zeros or one zero or even no zeros. But the key thing is it can have at most two. The number of zeros is simply the number of times its graph hits the x-axis. Are you starting to see a pattern here? The degree of the polynomial, like 1 for linear, 2 for quadratic, seems to be connected to the maximum number of zeros. Let's test that theory with a degree 3 polynomial, also known as a cubic.
Let's use the example y equals x cubed minus 4x. Looking at our table of values, wow, we hit the jackpot 3 times. When x is negative 2, y is 0. When x is 0, y is 0. And when x is positive 2, y is 0 again. That's 3 different zeros we found with just algebra.
And sure enough, when we actually graph this thing, we see this wavy curve that winds its way across the x-axis at those exact 3 spots, negative 2, 0, and positive 2. This pretty much confirms our suspicion. A polynomial of degree 3 can have at most 3 zeros.
Okay, so we've looked at degree 1, degree 2, and degree 3. We've seen a clear pattern develop. This all leads us to one simple, beautiful, and incredibly powerful rule that works for any polynomial, no matter how complicated it gets.
And here it is, the big reveal. For any polynomial of degree n, its graph will cross the x-axis at most, n points. And that means a polynomial of degree n has at most n zeros. So a crazy-looking polynomial of degree 5 could have 5 zeros, or 4, or 3, 2, 1, or none. But it could never have 6. The degree is the absolute maximum.
All right, you've got the rule, you understand the concept. Now it's time to put it into practice. Forget about the equations, forget about the tables of values. We're just going to use our eyes. Ready? Take a good look at this graph. Don't worry about what the equation is. Just focus on the curve and that horizontal x-axis. How many times does that blue line cross the black line? Count them up. That number, that's how many zeros this polynomial has.
Okay, let's see how you did. The first graph crosses just once, so that's 1 0. The second one crosses twice, 2 zeros. The third graph weaves across 3 times, giving it 3 zeros. The next 2 are back to just 1 crossing each. And that last one, it goes up and down, crossing 4 different times, which means it has 4 zeros. See? It really is that easy. Geometrically, the zeros are just the x-intercepts.
And that wraps up our topic for today. This was an initiative from the Roy's Academy faculty team. We've learned about the geometrical meaning of polynomial zeros from Chapter 2 of your CBSE Class 10 Mathematics course. For more explainers just like this one, remember to connect with us at Roy's Academy. The number is 8910890311. Again, that's 8910890311. And our other number is 8910600503. One more time, 8910600503. Thank you for learning with us.